Today we're going to talk about dividing polynomials. And we're going to take a look at a couple different ways we can divide. The first one we're going to take a look at is what's called dividing by a monomial. And if you remember, a monomial has just one term. So I'm dividing by a single term out here. Now there's a couple different ways we can do this. The easiest way to divide a monomial is simply to divide each one of these terms by the monomial. So I could change this division sign into a fraction bar. Okay, and instead of doing it like that, I can simply make it 3 separate fractions. And then all we're going to do is we're going to try and simplify or reduce each fraction. Okay, well 8 goes into 24 3 times. The a squareds cancel. And then these two b's leave me with 1 left over. So I end up with just, a 3b for the first term. Okay? When I go to the middle term, 8 goes into 16 2 times. Now look at these a's. There's 1 on the top and 2 on the bottom. That one goes away, leaving me with just 1 a on the bottom, and the b squareds cancel. So here I get a negative 2 over a. And the last one here, now 8 doesn't go into 12 evenly, but 4 can go into both of them. So if I divide both of them by 4, I get a 3 and a 2. A 3 on the top and the 2 on the bottom. And if you look at my variables, there's 3 a's on top and 2 on the bottom. Those two leave me with just 1 a on the top, and 4 minus 2 leave me with 2 b's on the top as well. Okay? And that just simplifies into 3 separate little terms. Okay? But again, when you divide by a monomial, when there's just one term over here, the easiest way is to divide it into separate fractions. Okay? And if I wanted to, just out of curiosity's sake, I'm just going to show you this because this might save you a little bit of writing. Rather than writing 3 separate ones, we can divide the whole entire thing by 8a squared b squared. And then just look at each one of these and simplify each one separately one at a time. You get the same exact answers as this for your first term, your middle term, and your last term. So whether you literally do 3 separate ones or write it as one great big one and then just reduce each one individually works just fine. Okay, we're going to try another monomial one here. Okay, so I have this trinomial being divided by that monomial. Okay, and well, maybe it's easiest just to do each one separately. 4c df, 4c df, 4c df. Okay, and then just look at each one separately. That might be the easiest. If I look at my first term out here, okay, oops, where'd it go? Okay, 4 goes into 25 times. This c leaves me with 3 c's left over, so I have a 5c cubed. That leaves me with 1d left over, and then the f's all go away. So I just get a 5c cubed and a d. When I divide my middle term by 4c df, 4 goes into 16 4. Notice it's a negative 4. The c's cancel, the d's cancel. There's 2 f's and 1 f. That one cancels out, leaving me 1 f on the top. Okay? And when I look at the very last term here, look carefully, that cancels, the c's cancel, the d's cancel, and the f's cancel. When everything cancels out, it doesn't turn into 0, it doesn't go away, but when everything disappears and cancels out, it turns into a 1. Okay? And that would be my final answer right there. Okay? But once again, when this is a monomial, we can just simply divide each one separately. Okay? So hopefully those aren't going to be too bad. It's basically just reducing fractions multiple times. Okay? However, what about if I do if I do division, and this denominator down here is not a monomial? If you notice carefully there, it's a binomial. It has 2 terms. Okay, well we can't do what we did just a minute ago. I can't just take a look at this and try and cancel it with that, that, and that. It doesn't work because of the subtraction sign there. When there's more than one term, that process we did just a minute ago is not going to work. So how do we do these then? When we have something that has addition or subtraction down there in my denominator? Well, we're going to go back and do what's called long division. And a lot of people get scared or nervous when they see that. And most of you guys haven't done long division since elementary school. Okay? But polynomial long division is actually easier than the long division you guys did with just numbers. But the process is exactly the same, and we're going to practice a couple of these here. Okay, so what I'm going to do is I'm going to rewrite this, the one I have right here, as a long division problem. Okay? Oops, is that the same one? Yeah, plus 7x minus 1. Okay? So I'm going to take this, 3x squared plus 7x minus 1, and I'm going to divide it by x minus 4. Okay? Now there's a little thought process that goes with this, just like you did in elementary school. What we do is I just look at the first term and the first term. And I'm going to ask myself, what do I multiply this one out here? This is the same for all of these. What do I multiply this number by to get that number? The first term to get the first term. Well, this is a 3x. I only have an x. I need to multiply it by 3. So I'm going to put a 3 right up on the top up there. And what I do with this number then is I distribute it, or I multiply it, to both of the numbers out in front. To both of them. You notice how I draw those little arrows. 3 times x is 3x. 3 times negative 4. Oh shoot, time out, back up. I need a 3 and I need an x, sorry. What do I multiply that by to get that? I need a 3x. I also need x, so that gives me 3x squared. There we go, sorry. And then minus 4x. And notice what I did here is I multiply. And maybe you remember from long division, what I do next out here is I subtract. And it's also greatly important that you write the subtraction sign with a circle around it, because I'll show you why in about 5 seconds. When I subtract these first terms should always go away. 3x squared minus 3x squared is 0. They disappear. Then I go to my next terms, and I do 7x minus negative 4x. And as you know, minus a negative turns into a change. And I actually end up with 11x. The vast majority of the people, if they don't write the subtraction sign and circle it out here, they're just going to do 7 minus 4 and get 3. So always write the subtraction sign out there. And then just like you did back in the day, we're going to bring down the negative 1. And we're going to do this one more time. I'm going to look at the number out in front, this x. What do I multiply it by to get this first term right here? 11x. Well, it already has an x, but that guy needs an 11. So I'm going to multiply it by 11, and it's a positive 11. Oops, a positive 11 up there. Okay, write that a bit nicer. I'm going to write it by a plus 11. And then I'm going to multiply just like I did with the 3. 11 times x is 11x. And 11 times negative 4 is negative 44. And I'm going to subtract. It's always multiply and subtract. Multiply and subtract are the two key words with polynomial long division. Okay? My 11s are going to go away. And again, I get negative 1 minus negative 44. I get a change. And I'm going to get 43. Okay? Now, I'm out of numbers to bring down. Okay? What's the significance of that 43? This 43 right here is our remainder. Okay? It doesn't divide it evenly. That's okay. But back in the day when you guys did remainders, you would write a big R 43 at the top. Okay, well, we're going to do a little bit differently. We're going to bring this up here, and this guy becomes a fractional remainder. It becomes plus 43 over the stuff that we divided by out front. 43 over x minus 4. And there's my grand finale answer up here at the top. 3x plus 11 plus 43 over x minus 4. And notice that remainder was a positive 43, so I wrote a plus right there. Okay, now it's a little confusing. Okay, it's a little different at first, but once you get used to it, it's not so bad. And I'm going to say this again, but what we look at is it's the first term and the first term. We multiply, subtract. And then we looked at the first term and the first term. We multiply and subtract. And we're going to practice a couple of these, and hopefully it's going to get a little bit easier. Okay, here's another one. Okay, how about this guy? Okay. Oh, and one other thing I should mention is the order of these numbers. It always has to go from biggest power to smallest power, and every power or term has to be accounted for. Notice it has an x squared. There has to be an x, which there is, and then a constant. And these things out here also go from biggest to smallest, an x and a constant. Okay, so it's all set up. It's in the right order. Things are all good. Okay? So let's try it. What do I have to multiply x by to get x squared? It needs another x. So I put that x up there. And the two keywords are multiply and subtract. So it has to multiply both of them. X times x is x squared. And 2 times x is 2x. There's my multiply. Now I subtract. Okay? X squared minus x squared goes away. 7 minus 2 is 5x. And then I bring down my 10. Okay, round 1 is done. Okay, how about round 2? I do it again. I look at the first number and the first number. What do I multiply x by to get 5x? Yeah, it's just a 5. Okay, a positive 5. So I'm going to write plus 5 up here. And I'm going to multiply and subtract again. 5 times x is 5x. 5 times 2 is 10. And then I subtract. Hey, look what happens here. 5 minus 5 is 0. They all go away. 10 minus 10 is 0. It has a remainder of 0. Okay, what does it mean if something has a remainder of 0? That means it divides in there evenly. Okay? Is there a need to write plus 0 over x plus 2? No, because 0 divided by anything is 0. So in this case, my answer is just x plus 5. Okay, with a remainder of 0. Okay? Oops. Okay, let's try one more here. Actually, I want you to try this one by yourself once. I'll help you rewrite it. X squared minus 13x plus 12 divided by x minus 1. Okay, see if you can push pause here for a second. Okay, take a minute and see if you can try this one by yourself. And then unpause and we'll go through it together. Ready, set, go. Hey, welcome back. Okay, let's try this. I'm going to look at the first digit and the first digit. What times x gives me x squared? Well, it's just an x. If I multiply, I get x squared minus x. And then I subtract. The x squareds are going to go away. 13 minus negative 1, that's going to be a change. It's going to give you, well, change, it's going to give you negative 12x. Write that a bit nicer. Negative 12x, and then I bring down my 12. And let's try it one more time. What do I multiply x by to get negative 12x? Now be careful. It's a negative 12. So it's a minus 12 up there. And if I multiply, I get negative 12x. And negative 12 times negative 1 is positive 12. And then I subtract again. Okay? I think 12 minus 12 goes away. 12 minus 12 also goes away. This one has another remainder of 0. Okay? And we'll see later on in this chapter that we like it when things divide in evenly and we get a remainder of 0. It's going to have special significance later on. Okay? All right, I got one last one here. Okay, look at this one. Whoops, and I forgot to write a squared right here. Okay, look at this one. It has just 4 terms under here. Is that okay? Yeah, we do the exact same thing. Okay, I'm going to start out front out here. Okay, with a and 3a cubed. What do I multiply a by to get 3a cubed? Okay, well I need a 3, and I need 2 more a's. It has 1. I need 2 more to get to 3. So a 3a squared. Then I'm going to distribute plus 12a, and then I subtract. And notice again, now, since this is a little bit longer, I should point this out. Third power, second power, first power, constant. Everything's in order, and every power in term is accounted for. Okay? And, oops, sorry, I did it again. This should turn into 3a cubed. 2 times 1 is the third power. And this should be 12a squared. I forgot my power. But if I subtract, these go away. 17 minus 12 is 5a squared. Okay, notice they're like terms, things line up, all is good. I bring down my 10a, and then I do it again. Let's look at the first term. A and 5a squared. What do I need to multiply a by to get 5a squared? It needs a 5 and an a. Plus 5 with an a. And just like I did with the first number, I'm going to distribute. I'm going to multiply, and I get 5a squared plus 20a. And then I'm going to subtract. Scoop this up just a tiny bit. Okay? When I subtract, the 5a's go away. 10 minus 20 is negative 10a. And then I bring down my negative 37. And here's a little clue. How do you know when you're getting done, when you're on the last round? Well, after you bring down the last number, okay, then we're done. Or not done, but that's going to be our last round. So let's try it one last time here. Okay, I've got an a, and this time I have a negative 10a. What do I multiply a by to get negative 10? Negative 10. And it already has the a, so there's no more a up there. But if I distribute, out there I get negative 10a, and negative 10 times 4 is negative 40. I have to go one more time here if I can squeak it up just a little bit. If I subtract, negative 10 minus negative 10, they go away. And negative 37 minus negative 40 is going to turn into a change, and I get a positive 3. And once again, this number way down here at the bottom is my remainder. And I'm going to go way back up to the top here in a second if I can squeak it in there. Whoop. This remainder of 3 is going to come way up here, and it's going to be a positive 3 over whatever it is I divided by. 3 over a plus 4. Okay? And my answer is this whole business up here at the top. 3a squared plus 5a minus 10 plus 3 over a plus 4. Okay? So sometimes we'll see a little bit longer polynomials. That's okay, just has a couple more steps to it. Okay, but we're not going to see any that have super big numbers, ugly numbers. It's going to be pretty straightforward for us. Okay? So that's long division. Okay? Different, a little bit different deal, but very similar to the way you did long division back in elementary school. Okay? Well, we're going to talk about, oh, here you go, I got one more. No, I don't. I'm going to skip to this one. This one says special one. Well, what's special about it? And you're going to see one or two of these on your assignment as well. Okay? So what's special about this? Doesn't look any different. But I mentioned this a couple times, but I didn't say it. Okay, well, I'm just going to start out, and don't write this down. I'm going to start out doing it the same way I did a minute ago. Okay, what do I multiply a by to get 5a cubed? Well, I need a 5a squared. I need a 5 and 2 more a's. If I distribute, I get 5a cubed minus 10a squared. And now if I subtract, those will go away, but right here I have a problem. How do I subtract a's with a squareds? They're not like terms, are they? So now what do you do? Okay, well, that's what made this special. I'm going to erase here for a second. I've mentioned this a couple times, and this is the first time we've seen it. Do you remember what I said about the stuff underneath the radical here? It has to be in order from biggest power to smallest power, and the most important part here is every power has to be accounted for. It's missing one. If you notice carefully there, it's missing the second power, isn't it? So how do you do that then? How do you account for that? Well, it's 5a cubed. How many a squareds do you see? There are none. So how do I write no a squareds? We write that as plus 0a squared. So technically, the way that I would want to write this, I'm going to have my a minus 2, and it would be 5a cubed plus 0a squared plus 7a minus 6. And that's something that you need to take note of, because you're going to see it. If it's missing a power, we have to put a 0 in there. And we'll see that here with the next types of problems as well. Okay? And then now I can do the same exact thing. Okay? Now I can fire away. I'm going to do this kind of fast. I would need a 5a squared. Then if I multiply, there's my 5a cubed and my 10a squared when I multiply. Those go away. But now I have a squareds and a squareds. I can subtract them. 0 minus negative 10 will be a change, and I get positive 10a squared plus 7a. And I can do it again. What do I multiply a by to get 10a squared? I need a 10 and an a. And if I distribute, I get 10a squared minus 20a. 10 times 2 is 20. I subtract again, they're gone. And here I get 7 minus negative 20. It's going to be a change. I get 27a. And here's my last round. I'm going to bring down that 6. Okay, let's go out front here and try it one more time. Oops, move this up a little. Okay, what do I multiply a by? Oops, I might get out of there. What do I multiply a by to get 27a? I need a positive 27. And if I distribute out there, I get 27a. 27 times 2 is negative 54. And if I subtract, those go away. 6 minus negative 54 is going to be a change again. And that turns up being positive 48. And that there again is my remainder. The remainder we're going to write back up top, and it's a positive 48. So make sure we write plus 48 divided by a minus 2. Okay? But be aware of, if it's missing a term, that we have to write a 0 in there. Okay? The powers, all powers have to be accounted for. Okay? All right. The last type of problem we're going to talk about is, division problem we're going to talk about is this one called synthetic division. And you're going to like this. It's a lot faster, it's a lot neater, and for lack of a better word, it's a little bit easier as well. Okay, so how does synthetic division work? Okay, so I kind of have a similar problem like we did before. 2x cubed, x squared, x 24 divided by x minus 4. Here's how synthetic division works. Okay, we start out by writing this great big giant L. Okay, and on the top line here go the coefficients of the dividend. Okay, so it's going to be 2, negative 13, 26, and negative 24. Okay, so it's those coefficients, just the coefficients. Okay, then we're going to put a number out front out here. The number that goes out front is the value of x that makes this divisor equal 0. Okay, so if I said like x minus 4 equals 0, and if I add 4, x would equal 4. Okay, and to make a long story short, when it's just a binomial out here, there's no number in front of x, it's the opposite of that number that goes out front. So there's going to be a big old 4 out in front here, a positive 4. Okay? So there's kind of the setup for synthetic division. We're going to use it a lot here, but this is the one we're mostly going to use as the chapter rolls on. Okay? So what we do here, this is how this works. We're going to drop down the 2, okay, to our starting spot here. Now if you remember in long division, the 2 keywords were multiply and subtract. With synthetic division here, the 2 keywords are multiply and add. Okay, here's how this works. I'm going to do 4 times 2 is 8. And I write my 8 right there underneath the next number. 4 times 2 is 8, and then I add. Negative 13 plus 8 is negative 5. Then I do it again. I take this number and I multiply. So I multiplied here first, but now I'm going to multiply out here. That's negative 20. And I'm going to add. 26 plus negative 20 is 6. I'm going to multiply again to get 24 and add. And I get that. I get it to be 0. Okay, so how does this translate back into our answers? Okay, well these numbers here are the coefficients of the numbers that I would have up here when I do long division. So I would have a 2, a negative 5, and a 6. Okay, and what about the variables? Notice it started out as x to the third. This is just one less power. It's 2x squared minus 5x plus 6. This number right here is just like the last number at the very end of long division. That's our remainder. So technically it's plus 0 over x minus 4. Okay? But 0 divided by anything is 0, and we don't write remainders that have 0. This would be my answer right there. Now again, that's something new and different that you've never seen before. But the more you use it, the easier it's going to become. But the 2 keywords there are multiply and add. Multiply and add. Okay? We're going to practice just a couple more of these real quick. I think I got 2 more. Okay? If I was to set this one up, my coefficients are the numbers that go up here, 2, 3, negative 4, and 15. And I put the opposite of this number out front. Again, it's the opposite of that number. And I'm just going to double check real quick. Is every exponent accounted for? third power, second power, first power, and my constant. So I don't have to worry about adding any zeros. They're all there. To get started, I drop down my 2. And then I multiply and add. Multiply and add. So negative 3 times 2 is negative 6. Then I add. 3 plus negative 6 is negative 3. Multiply is positive 9 and add. Negative 4 plus 9 is 5. Multiply, negative 15 and add, and I get remainder 0 again. Okay? If I take these things and I translate them back into a little polynomial expression, it's going to be 2x, and instead of the third power, it's 2x squared minus 3x plus 5 with a remainder of 0. Okay? There we have it. So this is what's called synthetic division. Okay? I'm going to see if you can try one by yourself here. Okay? I'm going to help you set it up real quick. So if I set it up here, it's going to be third power, second power, first power. They're all good. So 3, negative 8, 11, negative 14. And if I look carefully here, what number is going to go out front? It's going to be a positive 2. Okay? And I'll drop down my 3 as my starting point. I want you to take a minute, push pause, see if you can plow through it, and get a quotient. Ready, set, go. Okay? All right. Now that you tried it, hopefully, let's see what we get here. If I multiply, I get 6 and I add. Negative 2. Negative 4 and add, I get 7. Positive 14. All these have been remainder zeros, which is kind of nice. Okay? So if I translate this back into a polynomial, I get 3x squared minus 2x plus 7. Okay? Now once again, that remainder is not always going to be 0. Okay? If that remainder was, let's suppose this was a 5, then I would just have plus 5 over x minus 2. It just gets tacked on the end, just like we did with long division. Okay? But again, these remainders of zeros, as we'll see here in a few days, they're kind of special. Okay? All right. Okay. Let's try one more. One more of these. I see this one starts with a fourth power. Uh-oh. Fourth power, third power, and then it goes to b. It's missing the second power, isn't it? So when I start this out like this, I have a 6b to the fourth power, negative 8b cubed, but it's missing squared. So I have to put in a 0, b squared, and then 12b, and negative 14. So once again, same with long division. We have to do it here also. We have to put in a 0 if it's missing a power. So always, always check that carefully. You don't see it a lot, but you are guaranteed 100% chance of seeing it. Okay? And then that says b minus 2, so I'm going to put a positive 2 out front. Okay, let's plow through one last one, this very last one for the day. I get 6 to start with, so 2 times 6 is 12. I add it, I get 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. When I add there, I get 28. 2 times 28 is 56. And if I add here, I believe is at 42. I think it's positive 42. Now here's the first one with the synthetic stuff. We didn't have 0 as a remainder. We had 42 as a remainder. So I'm going to go back and rewrite this as a polynomial. And again, my answer drops down a power. It started at b to the fourth. So this is going to be b to the third. Plus 4b squared. Plus 8b plus 28. And then 42 divided by b minus 2. And there's my grand finale answer right there. Okay, so we're going to get a little practice with synthetic division today. And we're going to do this quite a bit, like I said, the rest of this chapter. And we're going to talk a little bit more later on about the importance of the remainder. And we're also going to talk more about the importance of these leftover numbers down here. But for now, we're just going to focus on the process. So once again, we divided by monomials. Okay, when this number was just a single term out here, we can just divide each term, make them into separate fractions, and simplify. Okay, we're going to see long division, where we got to do it the long way with our little radical. And then we're going to see most of them we're going to see today are going to be synthetic division. Okay? All right, thanks for tuning in.